Hi, welcome to this video about Angle Grinder by Schlappi Engineering. Angle Grinder is a unique combination of a filter section that's able to self-oscillate and a distortion section or waveshaping section based on 4 comparators. There's some interesting normalizations going on that make the module especially suited for gnarly feedback patches. But you can just as well use it as a clean VCO and a really versatile filter. I want to thank the people at Schlappi Engineering for sending me this unit to learn and demonstrate. And in this video I will cover the use of Angle Grinder as a VCO, as a filter. Then I'll take a closer look at what this comparator stuff is all about. And then at the end of the video I'll show you just some examples of how Angle Grinder behaves when you start combining all its functions. And because there's so much to talk about, I'll jump straight in, doing a quick overview of all the features of the front panel before playing you a few patches that I made with Angle Grinder. And after that I'll get started on a methodical overview of every part of Angle Grinder. Angle Grinder consists of 2 big parts, at least that's how I look at it. There's the grind section, which is mostly to the left here. There's these 4 sliders, and these sliders control how much each comparator section is added to the signal. At this point, probably none of this comparator stuff will make sense. It will be clear by the end of this video. You can control these VCAs with these sliders, but you can also send in external voltages to each of these inputs, which correspond to the slider above it. These inputs accept unipolar signals. They react to CV signals going from 0 to 5 volts, and the position of the slider is an offset, so the signals that you send in here are just mixed with the position of the slider. There's the grind input or main input, which is here. There's an attenuator for this signal. When nothing is patched into the input, this is normaled to the bandpass output of the spin section. This bandpass output goes through an all-pass filter, which means it gets phase shifted a little bit before going back into the input, and for this we need to turn up the input attenuator without connecting anything here. There is a separate grind output which we can use to extract the signal from this comparator side of the module without it going through the spin side of the module, which is kind of a filter. And there's a knob here that controls how much of the grind signal is routed through to the spin side or filter side of the module. When you turn this completely to the right, everything that you send into the input of Angle Grinder gets routed through to the spin side, which is, as I said, the filter, but you can use an additional inject input to just bypass the grind section, and everything that you send in here will be routed directly to the spin side of the module. There's a knob for damping, which is kind of a reverse resonance control, by which I mean if you turn this to the right, the spin side just behaves like a filter, but the more you turn it to the left, the more feedback is added, and this is just like a resonance control on a regular filter. And of course, if you turn it completely open, which is probably counterintuitively to the left here, this filter will start self-oscillating and you can use it as a VCO. There's 4 outputs here. When using as a filter, the first one is a low pass output. The second is a bandpass output, then there's a high pass output, and then there's an inverse bandpass output as well. When the spin side of the module, when the filter is self-oscillating, these 4 outputs, just like with any other filter, output sine shapes with different phases. The second one is 90 degrees out of phase with the first one. The third one is 180 degrees out of phase with the first one, so it's just the inverted signal. And then the fourth one is 270 degrees out of phase with the first one. And you can actually see the oscillations of these 4 outputs when you look at the blinking lights here. Currently, Angle Grinder is set in the low setting here. So currently it's more behaving like an LFO, but you can switch it to audio rates using this switch here. At which point this becomes an audio rate oscillator, which sends out 4 phase shifted sine waves. Angle Grinder tracks really well when you send a sequence into the volt per octave input here. And then there's 2 FM inputs. The first FM input has an attenuator. When you turn this knob to the right, when nothing is connected to the first FM input, it uses the output of the grind section for frequency modulation. At the back of Angle Grinder, there's a header which lets you choose between linear and exponential frequency modulation for the first FM input. And then there's a second FM input, which is just an exponential FM input without an attenuator. There's this big knob that sets the frequency of Angle Grinder. And finally, there's a fine control for the frequency. Probably using angle grinder as a filter is the least confusing use of the module. So let's run a sound through angle grinder and just listen how it sounds as a filter. We will be listening to this sound. This is the sound going straight to the mixer. This is just a chord from the 4MS ensemble oscillator, but let me patch it through to angle grinder. Now, the main input of angle grinder, the one you would probably be using most of the time, is this one. There's a separate input here called inject, which goes straight to the spin side of angle grinder without going through the grind section with all these comparators. So let's just use this one. So I've connected the cord to angle grinder's main input here, and let's turn up the attenuator for the input. And I should turn this one down as well. Notice how both these knobs are towards the filter side of things. And right now I'm listening to the first output, which is the low pass filter. And let's give it a sweep. I think this filter sounds really nice, especially with those chords. When you're using angle grinder as a filter, you can look at this knob, the damping knob, as kind of a resonance control. When it's turned completely to the right, the feedback or resonance is completely down. But let's bring it up a little bit. Let's bring it up a little bit more. This is really lovely, at least in my opinion. Let's see how it behaves when we crank up the resonance a lot. And let's bring it up even more. And some more. And when you turn it completely to the left, which means the resonance is completely up, as with most filters, angle grinder starts self-oscillating, and then you can just use it as a VCO, and that's why there's OSC printed here. But we'll get into that later. First, let's listen to the bandpass output, or bandpass. I'm never sure how to say it. Normally I just say bandpass, but I don't think that makes any sense. But I think you know what I mean. So the second output is the bandpass, whatever. Let's do a sweep. And as with all bandpass filters, the volume goes down a lot because there's a lot of frequencies being cut out. And that's why generally with a bandpass filter I turn up the resonance more than I would with a low pass filter or a high pass filter. So let's listen to it with the resonance set at this point. Let's turn it up a little bit more. Even more. More still. Sounds really nice in my opinion. Please notice that this switch here is to the right, so we're in the high or audio rate setting of angle grinder. Now let's listen to the high pass filter with the resonance completely down. Yeah, this sounds nice as well. Let's turn the resonance up a little bit. Let's turn it up even more. And even more. A little bit more. You can start to hear this bass boost that's so easy to get with a high pass filter. right around here. Now this is something that's really cool to modulate with a sample and hold, but I know I'm doing sweeps, but I just have to try this now. Let's use this input. Now let's listen to the last output here, the fourth one, which is the inverse bandpass output. And I'll show you in a minute how you can use this to create a phaser. But let's first listen to it. No, let's turn down the resonance first. Okay. Let's turn up the resonance a bit. A little bit more. Even more. And then you can see at this point it starts self-oscillating, so let's back it off a little bit. Yeah, like that. Now, like I said, using this output is a great way to create a phaser. For this, you just need to mix the output of this inverted bandpass with the dry sound. And to sum these two signals, I'm just going to use SumDiff by Shakmat, which is a really useful utility module, which I will make some kind of extensive video about at some point. So we're listening to a mix of the dry sound and the inverted bandpass output. And you can hear when I sweep the frequencies, this behaves like a phaser. Should I connect some modulation to it? Yes, I should. Let's slow it down a little bit. Let's play around with the resonance of the filter. Let's add some reverb to this. Now I've connected a saw wave that I generated with Generate 3 to the angle grinder input. And let's open up the filter, turn down the resonance, and turn this attenuator for the first FM input to the left, because when nothing is patched in here, it creates feedback from one of the outputs. So if nothing is plugged in here, and you don't want any weird feedback going on, you really should turn this knob down. And let's just bring up the attenuator for the input. And as you can see, we have a beautiful saw wave. There's no clipping going on. But you'll see when I now turn the FM knob to the right and nothing is plugged into the input, you get some kind of, yeah, I would say it's clipping, but it's not really clipping. It changes the wave a little bit. So you can get around this by just turning down the input attenuation. But let's turn the FM knob down as well for the time being. And let's quickly do some filter sweeps with this sound going in. But instead of me turning the knob manually, I'll just use one of the several CV inputs that Angle Grinder has. And you can choose from 3 FM inputs. There's the Volproductive input, which is an exponential FM input without an attenuator. Then there's the FM1 input, which is in the current setup linear frequency modulation, but you can change a header on the back of Angle Grinder to get either a linear or an exponential response from the FM1 input. And then there's the FM2 input, which is another exponential FM input without an attenuator. So let's just connect a saw wave to the second FM input and listen to some sweeps this way. Let me turn up the rate of the LFO. You can see at some point it stops behaving regularly and there's some weird clipping going on because the filter is trying to self-oscillate. And I guess the levels get so high internally that the module starts clipping, but I'm pretty sure this is how it was designed. So let's quickly run through the other filter outputs. Now we're listening to the bandpass output. And you can hear when I use the FM1 input, because currently this is a linear FM input, the effect of the modulation is much less pronounced. And you can use the Volproductive input as well, which in theory should yield a similar result to using the unattenuated FM2 input. Let's go to the high pass output. And let's just, for the sake of it, listen to the fourth output as well. Now let me quickly set up a patch where I use all 3 FM inputs to demonstrate how you can use these in an interesting way. So I've just connected a random gate to boundary, which is just off screen, but I think you can see the trigger or gate I'm sending into it. And I'm going to use the envelope output to send to the first FM input here. Then I'm just going to use the gate output from my sequencer to send to another function generator. I'll connect the output of this module, which is just another envelope, to the second FM input. I can attenuate the level of this envelope on the module itself. I'm using a delta V. can hear that using 2 inputs to send envelopes to gives us far more interesting results than just using 1 envelope. And then I can use the volt per octave input on Angle Grinder to send my sequence to. So it kind of follows the pitches. Then I can use the inject input to just add another sound into the filter. Yeah, this sounds great. Let's listen to the bandpass output. Let's add some resonance. So I've removed the second VCO going into the inject input. So we're just listening to the saw wave that was going in earlier. And let's just keep all the settings and all the modulation and listen to what happens when I just connect this sound to the inject input. And as you can see, there's only mayhem, but this is because this is not attenuated. And as you can hear, it's barely there, but it is there. So let's have a quick look at using Angle Grinder as a VCO or LFO. I'm going to stick to the high setting here, but everything that I'll show you, you're also able to do when you switch Angle Grinder to the low or LFO setting. So there's nothing going into the input here. The input attenuator is down, so there's no feedback from this circuit here going back in. This attenuator is down as well, so there's no feedback coming from the grind section either. At this point I can turn this knob to the right or to the left. It doesn't really matter because there's nothing going into Angle Grinder anyway. Normally you would use this knob to adjust the amount of signal that's coming from the grind section and going into the spin section. And at the moment we're listening to the first output here. The second output just gives the exact same signal, but it's 90 degrees out of phase. You can see these are just all the same sine waves. They're just shifted. And you could use these patched in stereo for some kind of stereo spread, but then it's best not to choose the first one and the third one, or the second one and the fourth one together, because these will cancel out. But anyway, let's just stick to a mono signal here. So this is our sine wave, and just like any other VCO, you can send a sequence into it. And then I'd like to show you how the FM inputs behave. So there's the first FM input, which is currently still set as linear FM. I'm just going to send a sine wave into it coming from generate 3. And let's open this attenuator. Let's play around with the frequency of generate 3, which is the modulator at this moment. Of course, you can melt your sequence and send it to the modulator as well. And then there's the exponential FM input, or the second FM here. This input has no attenuator, but I'm attenuating the signal beforehand. So let's now open it up. So as you can hear, exponential frequency modulation is a lot more extreme. And if you start attenuating your modulator, you can get really interesting results from using FM. Let me quickly route an envelope to my modulator. And just because we're here anyway, I'll route the second output. I'm not going to send it through the scope, but let's send both of these outputs to my mixer band left and right. And then you can hear stereo FM. Let's remove this FM signal. Now, by turning the input knob to the right here, and then turning the FM knob up, you can get some feedback going into the VCO, which changes the shape a little bit. And when you turn this knob to the right, you leave the FM knob to the left, so completely closed. And then you start turning this knob to the right, which injects the grind circuit into the spin section. I already dropped the levels on my mixer because this can get really loud and harsh, as you'll see and hear. It's stated in the manual that these signals can get really loud, so it's just something to be aware of. So when in low mode, you of course can use these 4 outputs as quadrature LFOs to trigger sounds or modulate parameters around your system. But I'm sure you can figure out how to use an LFO by yourself. Let's have a look at the comparator side, or the grind side of Angle Grinder. As you can see, I have connected the 3 first angle outputs, which when you set up Angle Grinder like this are just phase shifted sine waves. So I connected these first 3 to the inputs on data, and the first input on data is reserved for the grind output. But for the moment we're just watching the green trace, which is the grind output, and the blue trace, which is just in this setup the first sine output of Angle Grinder. Please notice that there's nothing going into the grind input here. This is the general input, or the main input of Angle Grinder. There's nothing going in here. and this knob for input gain is completely down. I've also turned the grind or spin routing knob completely to the left. When this is completely to the left, we're not driving the grind section of Angle Grinder into the angle section, but we'll get to that later. Just note that this is completely to the left, and the damping knob here is completely to the left as well. And then of course there's these 4 sliders that you can use for opening VCAs with outputs of comparators that compare the incoming signal, which at the moment is nothing, to the 4 different phase shifted sine waves of this part of the module. You'll see that when I turn up the first slider, the green line, which is still the grind output, changes, and this has some correlation to the blue trace beneath it. And I made a diagram to make more sense of this. The green line represents the grind input and output, which are all 0 at the moment, and the blue trace represents the first sine wave. Then when you move the slider upward, you're gradually opening the VCA of the comparator circuit, and what this first comparator outputs is essentially just the solution to the simplified question: when is the blue line above the green line? The circuit inside Angle Grinder takes this output and it subtracts this from the input signal, which is currently 0. And as you can see in the real life Angle Grinder, this gives us a pulse wave that has a correlation to the first sine output. Now let's unmute the other outputs. Ideally, I would also connect the 4th spin output to the oscilloscope, but because I also want to monitor the grind output, I just don't have enough channels. But I think watching the first 3 will be revealing enough to get a sense of what's going on with these comparators. Now let's take a moment to just focus on the red trace, which is the output of the second sine output here, which has a phase shift to the first one. And then when you open the VCA for the comparator, you will see that indeed the dips in the square output we're getting from the grind output correlate with the bumps on this sine wave. So the second comparator does exactly the same as the first one. When is the red trace above the 0 axis, and then it subtracts this signal from the input signal. The same goes for the 3rd comparator, which then correlates to the bottom trace here, the yellow one. And with some imagination you can imagine that the 4th one does exactly the same thing, but it compares the input signal to the 4th sine output on Angle Grinder. And it's when you start combining these separate comparator outputs that all feed into the grind output that you can get these stepped shapes. Now, as you can see, because the first and the 3rd slider look at waves that are just the opposite of each other. Let me mute the red one here. You can see that the blue trace and the yellow trace are just inversions of each other. This is because the blue output and the yellow output are 180 degrees out of phase. So when you start comparing these to 0 or to whatever you send in really, but now we're just sticking to nothing. So when you add these together, you can see they cancel out. It's not perfect. For the most part, they just cancel each other out. Now you can still use these in interesting ways to make things less or more symmetrical, as you can see. And by routing a CV signal into these inputs, which react to 0 to 5 volts, the sliders are an offset to whatever you send in. When you start sending CV in, you can really animate a sound, but when you are not sending anything in, these will always be somewhat square or stepped. Now, from the moment that you turn the knob for the input here to the right, so you increase the input level, you'll see that the green trace starts changing its shape, and this is because there's an output of this section here, the spin section. There's a sine wave normalized to this input, so whenever there's nothing patched into the input, you can just add the sine wave. By the way, the sine wave that is normalized to this one is a sine wave that's going through an all-pass filter, and what this essentially does is just phase shift it a little bit. This is just so that it wouldn't cancel out when starting to compare them. And then of course you can see that you can get all these interesting shapes by just using Angle Grinder by itself. Now I realize that this all is very confusing, so let me just take one step back. So we're back at the situation we were before. There's nothing going through the comparator circuit, and these are of course still the first 3 sine outputs showed here, which you can see here as the 3 bottom traces. So now I will add something that's going into the input, and then of course we need to turn up the input knob here for this to come through, and I'll just add some positive offset with mats. Now even though this offset is positive, the green light for the LED cable means it's positive, so we're sending in slight positive voltage, and you can see that on the output of this grind circuit the voltage actually drops. I'm not sure why this is, but I assume the reason behind this is for not cancelling out at certain settings or something like that. It doesn't really matter. So by sending in a positive voltage, the signal output of the grind section goes down. And you can also see on the diagram that there's a smaller portion of the blue line above the offset. And this signal, this comparison, the output of this comparator, again will be subtracted from the signal we sent into the grind input. So when we then turn up the slider, we see something like this. And the same thing of course applies to the comparators for the other phase related outputs. And then by sending in a current that changes, now I'm just doing it manually. I'm just turning the knob that sends out the bias or the DC offset to increase or decrease it. And you can see that you get all these interesting shapes. Now of course it's a little bit silly to be doing this manually when you just can connect an LFO to this. And I'm sure by now It would be nice to actually hear what this sounds like. Let me bring in the signal. Now I turned up the frequency of angle grinder with this knob, by the way, to around the center position, because the behavior of the comparator outputs, at least the shapes it generates, change a little bit with different frequencies, and I wanted them to be the same shapes that are printed in the extensive manual to angle grinder. I also wanted them to be the same as the diagrams I made. So now we're just listening to the grind output, but let me connect two of these sine outputs, which of course operate at the same frequency, and let me add them to this mix, perhaps band left and right. Let me lower the signal of the grind output on my mixer. And let's just, for the sake of it, connect a volt per octave sequence to the volt per octave input on angle grinder. And now when I turn this knob here to the right, I send whatever the grind output is doing into the spin section, which of course creates really interesting feedback situation, because the grind output will be mixed together and present at these sine outputs, which in turn are used to compare whatever's coming in here too. And this, let me show you, is of course a chaotic mess, which can be really pleasing. More unique things start to happen when you start combining all these different features of Angle Grinder. And because this video is starting to become a behemoth, I'll just quickly run you through a few of the cool things that I discovered on Angle Grinder. Let's first listen to just a sine wave that's going through Angle Grinder. The blue trace is the sine wave going in and the green trace is the grind output. I have Angle Grinder self-oscillating, but it's at the low setting, and now I can just start comparing the input, which is the sine wave, to the LFO of the spin section. And this already gives really interesting distortion type effects. The rate of this modulation is controlled with the speed knob or frequency knob. But you can just as well flick the switch to the right, at which point we're comparing our sine input coming from a generator 3 to the internal oscillator, which is now oscillating at audio rates. And if you now start modulating the frequency of Angle Grinder by just, for example, sending an LFO into one of the FM inputs, you can really bring a sound to life. Of course, you can connect modulation to any of these sliders or all of them as well. I can turn down the modulation here. Let's choose another input to modulate the frequency. And then by just turning up the first FM attenuator, which causes feedback to happen, you can increase the level of mayhem that Angle Grinder is spitting out. Now instead of sending in an VCO at audio rates, I'll switch to low mode on generate 3. And as you now can see, I'm sending in an LFO. It's going to grind input. We're still monitoring the grind output, which is the green trace. And if I now slide up these sliders, you get something like this. Now I'm sending in the same LFO, which is still the blue trace. It's just turned down here. So essentially, when nothing is connected to the input and angle grinder is oscillating, you compare the different phase outputs here to whatever's going in, which is 0. And as I showed you before, you can get these stepped waves. But if I now connect the LFO back to the input and I turn up the attenuator just a little bit, you can see that we can get PWM sounds out of angle grinder. And yes, they go through 0. And then again, if you start modulating any of these sliders, things start sounding a lot more interesting. Of course, you can still use the normalized feedback routing. Which causes all kinds of really cool things to happen. And of course you can turn the LFO into a VCO. Which can give you these kind of effects. Let's modulate the frequency as well. And then you can still use the Volproactive input to send a sequence into angle grinder. But perhaps it's better to send this to the oscillator that we are sending into angle grinder. Turn down the frequency of this oscillator. And you can also melt this sequence and send it to both the oscillator and angle grinder. And let's use yet another LFO to modulate an extra slider here. And now let's just listen to what these outputs are sending out. Let's remove the modulation to the frequency. And let's send some of the grind signal to the filter. Which can cause really loud spikes, as you can hear. But if you're careful, you can get really great sound from this. And if you think that by now I still know why this is behaving like this, I have no idea. There's too much feedback going on to make sense of it. And I think the whole point of this section is just to show you that it's really rewarding to just start experimenting with essentially every knob and every input and output. Let's listen to the bandpass output. So now we're listening to the high pass output, and these knobs are turned completely to the right. Let's remove the modulation to the sliders. Let's turn them up manually. And it's the bottom trace that you need to look for. This is the output of the high pass filter here. Got some feedback there. Let's turn up the resonance. And again, this is causing all sorts of mayhem, which I really like. Let's perhaps take an attenuated LFO to send into the FM2 input. So now I just turned down the frequency of the oscillator that I'm sending in. Even just by itself, angle grinder makes all sorts of ruckus. You can spend weeks with this thing and just always find new sounds. It's kind of crazy, but I think that was the whole point of this module. Now there's one more thing that I really wanted to show you. If you switch angle grinder to the low setting, you connect nothing to the input and you turn this attenuator down. You turn this down as well. So there's absolutely no feedback going on. You turn these knobs to the oscillator side. And sometimes you need to turn up the frequency to get it to start oscillating. And then when we listen to or I should say when we look at the grind output, we can see, of course, at the moment there's nothing there. And now you can see that by sliding of these sliders, you get these stepped patterns. And you can use these patterns just as interesting LFOs, or even for sequencing a VCO. Let me connect this green trace here, the green cable, to the Volper octave input on a VCO. And if we then listen to this VCO, we should be able to hear something more or less musical. And you can turn down the rate of the oscillations and therefore the tempo of the sequence. You can even clock other sequencers to Angle Grinder by connecting one of the outputs of the filter or spin section, which, as you can see, is an LFO. This does not work for every sequencer or clock divider or synced LFO, but for some it works. If you now just connect this to the tempo input of whatever you're sending it to. Right now I'm just using a synced LFO, and now I'm using the output of this synced LFO to modulate the timbre of my VCO. And this is a really interesting way to create sequences on the fly with Angle Grinder, and even having the option to clock other things to it. And now if you start introducing feedback, you of course change the shape of the sequence, because this knob is normalized to an all-pass version of the bandpass output here. So of course you're going to see some correlation between these LFO outputs and the green trace we're seeing here. You can also introduce some feedback of the grind output itself. And when you just start turning knobs, you can make everything behave just strange, really. And then when you modulate any or all of these sliders, I'm really convinced if you send this kind of signal to a quantizer, you will really get interesting melodies out of it. Once again, many thanks to the people at Schlappi Engineering for sending me this module. I will be doing an overview of Boundary, which is just to the right here, just off screen. The build quality on these modules, by the way, is just outstanding. The knobs they just don't wiggle at all. The sliders and the switch here all feel really good. And there is really a great deal of ingenuity that went into making this module. I hope you learned something by watching this video. Let me know in the comments if you have any questions. And if you really liked the video, perhaps you can have a look at my Ko-fi or Patreon page. Many thanks to the people who already donated a few dollars or euros there. It's really much appreciated. Thank you very much for watching this video. I see you next time. Bye.